Hi everybody, today we are going to solve polynomial equations. So the first thing we're going to do is just solve an equation. It's already equal to 0, and we're going to solve it, and the way I'm going to try is factoring. So that's always my first go-to, and since this has 4 terms, I'm going to make it into 2 groups. I'm going to take out the GCF. So the greatest common factor in my first group is x squared, and I'm left with x plus 3. My GCF in my second group is -2, and then I'm left with 2x, and then -6 divided by -2 is plus 3, and by 2x I really just mean 1x, whoops, plus 3. So remember that what's in your parentheses has to be the same, and then you take out the GCF one more time. The GCF is x plus 3, and you're left with x squared minus 2. So then you always check to see if you can factor it again, but this isn't a difference of squares, so I just have to solve it from here. So I'm going to use my zero product property, knowing that I have 2 factors. I need to set them both equal to 0, and then I need to solve. So if I subtract 3 from both sides, I get x equals -3. Here I'm going to add 2 to both sides, so x squared equals 2. Take the square root to get rid of the exponent. X equals plus or minus square root 2. All right, so don't forget your plus or minus because that is 2 solutions, right? That's positive root 2 and negative root 2. And then I have a -3, which gives me a total of 3 complex solutions. So make sure that you know that since it's degree 3, it's going to have 3 solutions. Also make sure that you know all factoring methods. So that's grouping, sum and difference of cubes, difference of squares, just a trinomial, so we can be ready for all the types of problems we might see. Okay, so number 2, it says find the zeros of the function and then sketch a graph of the function. So the zeros happen when your function is equal to 0. So that's x to the third plus 2x squared minus x minus 2. And then I need to take the GCF because this has 4 terms. So I'm going to factor by grouping. So x squared, then I'm left with x plus 2. Then my GCF, well, there isn't a specific GCF between x and 2, so it really is -1 because there's a negative here. So then I'm left with x plus 2. So I take out the GCF one more time, so x plus 2, and then I have x squared minus 1 left over, right here. Order doesn't matter, but I still have to check to see if I can factor it again. So I have x plus 2. This is a difference of squares, so that becomes x plus 1, x minus 1. And then I'm done factoring, but I actually have to solve it in order to find the zeros. So that means x plus 2 equals 0, x plus 1 equals 0, and x minus 1 equals 0. Setting each factor equal to 0, you get x equals -2, x equals -1, and x equals 1. So then I have to sketch the graph. So I'm going to do this. I'm going to talk through it and how I'm going to do it without a calculator, but you have a calculator, so you could definitely look on the calculator. 1 0 is at -2, 1's at -1, and 1's at +1. So this has a degree of 3 and a positive leading coefficient. So I know that when it's a degree 3, it's a cubic function, and I have an idea what that looks like. A positive coefficient means that my end-to-end behavior, like all the way to the right, is going up. And then I need to go through each of the zeros. But I'm going to redo that because I missed one. Okay, so go through each. We have opposite end behavior because it's a degree 3, this is a cubic function. Now, you could also type this in your calculator, so if you want to take a second right now, go to y equals, type that in, and you'll see the graph as well. So either way is just fine. Okay, so number 3, write a polynomial function of least degree that has a leading coefficient of 1 and zeros of 3 and 1 plus 2. Root 2, sorry, 1 plus root 2. So there's something called the irrational conjugate theorem. And that means when you have an irrational root, like it has a square root, its conjugate has to also be a 0. So that means its conjugate is 1 minus root 2. So both of those have to be roots because of this theorem. So then I'm going to write these as 0. So x equals 3, x equals 1 plus square root 2, and x equals 1 minus square root 2. So to write a function, we need to find the factors first. So I need to set all of these equal to 0. So that would be x minus 3 equals 0, x minus 1 minus root 2 equals 0, right? Subtract both of them. Then I need to subtract the 1 and add the root 2 to the other side. So once you have all three set equal to 0, you have your three factors. So that would be x minus 3, x minus 1 minus root 2, and x minus 1 plus root 2 equals, I'm going to write f of x because we're writing a function of f. So now I have to write it in least degree, which means I need it in standard form. Right? This is factored, and I need it in standard form. So I have to multiply this out. Now you can only multiply 2 at a time, so I suggest multiplying these two together. And you can distribute. You'd have to distribute the x to everything, then you'd have to distribute the 1 to everything, and then you'd have to distribute the square root 2 to everything. So I prefer to make a rectangle to help me stay organized, but you could do either method that you like. So I need a 3 by 3, and I have x minus 1 minus root 2 and x minus 1 plus root 2. And I need to multiply. So x times x is x squared. Negative 1 times x is negative x. Then I have x root 2, negative x. Negative 1 times negative 1 is positive 1. Negative 1 times square root 2 is negative root 2. Then I have negative x times, or negative root 2 times x is negative x root 2. A negative times a negative is a positive root 2. And the negative square root 2 times a positive square root 2 is negative 2. So that leaves me with x squared, negative x minus x is negative 2x. Then I have a negative x squared and x root 2, negative x root 2 and a positive x root 2 cancel each other out. Same with this negative square root 2 and positive square root 2. Those cancel each other out. So then I have 1 minus 2 is negative 1. But I can't forget about this x minus 3. I have to multiply this then by x minus 3. So you'll probably have to flip your note sheet over to continue this problem, and that's okay. We ran out of room, so you're going to flip it over, and we're going to multiply this together. So x minus 3 times x squared minus 2x minus 1. So again, I am going to make another rectangle. You could just distribute whatever makes you happy. So I have a 2 by 3, x minus 3, x squared minus 2x minus 1. So x times x is x to the third. Then I have negative 2x squared and negative x, when I'm just multiplying these together. Negative 3x squared. A negative 3 times a negative 2 is a positive 6x plus 3. Right? Negative times a negative is a positive. So then I combine my like terms. I have x squared, or x to the third. Negative 3 minus 2 is negative 5x squared. 6 minus 1 is 5x plus 3. So f of x equals x to the third minus 5x squared plus 5x plus 3. All right. And there you have it. That's how you write a function in least degree. All right, so I have one bonus problem that we're going to do. It's pretty quick. So it's awesome. You're going to love it. So everybody needs to write this down. Sketch a graph with zeros at -4, 0, and 5 with a local max at x equals 2 and a local min at x equals -2. Okay, so let's sketch this. I need zeros at -4, 0, and 5. And then I need a local max at x equals 2. Well, it doesn't matter where you put it. It's just telling me it has to be a max. So it has to be somewhere up here. Yours might be all the way up. Maybe it's shorter. But it just needs to be a local max. And then there's a local minimum at -2. So I'm going to go down here. But again, it doesn't really matter. So my graph has to go through all of these. So it needs to go through here, down, up through 0, through the max, and down through the 0 at 5. So it just has to fit all the pieces given, and you're good to go. All right, write down any questions that you have so you're ready to ask them when we meet next time. See you then.